It's a pleasure to be here, and I think it's really a great topic, and this is not a kind of meeting that I've attended before, so I'm finding it interesting. When I saw that the title was AI and Safety, it occurred to me that there are two parsings of this title, and I think it's fair to say that most of the talks so far have been about the question of how to make AI systems safer. And we just, for example, saw from Richard a list of research going on in that area. When I think about safety, by the way, I'm a person who's been accused multiple times by my wife and others of not worrying enough. But when I try to worry, what I find myself worrying about is terrorism, errors in the healthcare system. I was told today that the third leading cause of death in the US is errors in the healthcare system. I worry about nuclear power plants being run safely. I worry about the power grid, making sure that we actually have electricity. If we don't, that would be a very serious failure of a system. And to be honest, when I try to worry, those are the things that come to mind as the big deals in 2016 today. And so when in this talk, what I want to do is just get us to think about what would it mean to use AI to make those kind of systems safer. And my talk is very simple. I only have 3 observations and 2 recommendations. So let me take you through each of those. So the first one is that if I want to make complex systems safer, like let's say, I don't know, a nuclear power plant. And a complex system, by the way, could be a hardware thing like a nuclear power plant or an airplane, but it also could be a process like a financial market. I want financial markets to be safer too. They're not a physical thing, but they are a system. And we can think about both physical and other kinds of systems and what it would mean to make them safe, what it would mean to detect failures in those and to respond appropriately to those. So in fact, if you think about how those things can fail, you see it's not just because of AI. It's not even just because of software. Those things fail because of human errors, because of machine failures, mechanical failures, because of stacks, because of computer errors, lots of things. But it seems to me that if we're going to mount a science or a discipline around making complex systems safe, then number one, we should look at not just complex systems that are built on AI, and also not just on failures that come from AI, but look realistically at these many causes of failures. And then if you ask, what can we do there? Well, in fact, you know, if my car starts veering out of the lane, I don't really care whether it's because one of my tire pressures was low, or there was a computer error, or there was a driver falling asleep. I just want to detect that failure mode, and then I want to remediate it. And so, in fact, there are in cars that you can buy today now lane drift detectors that will push your car, at least push your steering wheel, back into the lane where you should be going. So the point of that is that regardless of the failure source, there are things we can do. We can detect the failures. Sometimes we can even detect the precursors of failures, and we can respond to them, for example, by pushing my car back into the lane, or in the case that the cores in my nuclear power plant are overheating, by shutting down the nuclear plant, even if I don't know the cause. And in fact, to get safety in these complex systems, what we want to, of course, do is work at both the component level, I'd like for example, in my car, I'd like the anti-lock braking system to be working. I'd like the tire pressures to be correct. And in fact, in most cars today, there are sensors that will tell you, you can buy cars where your sensors will tell you whether your tires are correctly inflated and will give you a warning if your anti-lock braking system isn't working. So we do want component level sensing and remediation of failures within the components, but equally importantly, at least equally importantly, we want at the system level things like that lane drift detector that will say, well, the overall system is not doing the right thing. I don't care whether it's human error, machine error, or I just want to fix it. So that's point number one. Let's think about how complex systems fail. Realize that we can look at component-wise reliability of parts and system-wise too, and that if we can detect and remediate those, that's an avenue toward some success. Okay, point two, AI is one clear technology that can help with these things. If you think generically of a kind of AI system that has sensors and effectors into its environment, then whenever we have a complex system, as engineers, we could try to design sensors and effectors that hover over that complex system, whether it's a nuclear plant or the financial system, that try to perceive its current state and its current direction that it's evolving, try to anticipate what state it's going to fall into next, and if that triggers some condition that we don't like, that could be defined in advance, like drifting out of your lane or overheating, then it could respond with its effectors to, for example, push the car back into the lane or shutting down the nuclear power plant. So AI can help, and in fact, if you look at the progress in AI over the last decade, let's say, I think, in my opinion, in many people's opinion, the most dramatic progress in AI over the last decade has really to do with perception and the new ability of AI system to actually perceive the world. Errors in computer vision systems have dropped by about a factor of 2 over the last decade. Speech perception works, and generally because of things like deep network learning algorithms and other reasons, AI systems now are much better than they ever had been before at perceiving and recognizing how to and interpreting sensor data, whether it's images or sounds or other kinds of non-human sensors like electrical sensors and so forth. So because of that advance, there are actually lots of opportunities for building AI systems, basically perception systems that can perceive many things that didn't used to be perceivable. So, and you see some of this creeping into the design of new automobiles, but we could also go back to old systems that we never thought of instrumenting with sensors and start throwing just lots of sensors into these systems. You could imagine going back, let's say, to chemical power plants. Well, maybe that's not the best example because they're pretty heavily instrumented already, chemical refineries. But even in those situations where they've been engineered years ago with individual sensors to give feedback and to control. Let's go back to cars. It's easier because we're all familiar with cars. My car does have a sensor inside the tire that tells me when the pressure is too low. I thank God that it's not making decisions based on that sensor, because once a year it tells me the tire is too low and I shouldn't drive, and it drives my wife crazy and she won't drive until we go to the car place and get the sensor fixed. So one thing, now that sensors are cheap and processing is cheap, we should never have decisions based on single sensors. If that sensor has a chance of 1 of 1,000 failing, 1 day in 1,000 failing, and there's a critical decision that it's based on that sensor, then that's just crazy, right? We should have not only that sensor in my tire, we shouldn't get rid of it. We should just augment it with other sensors. You can put a little camera, stick it into the fender of the car and look at the tire and see whether it's in fact at the right radius. And we'll put a little thermometer in there too to check what the temperature is. So then we can use whatever that law is that relates pressure to temperature and so forth. Okay. The point is, this technology is inexpensive enough and it works well enough now that it's kind of foolish to have any kind of decisions based on single sensors. We can afford increasing the reliability of those and therefore the decisions on which those things are based. Here's a second example of an existing system that we don't think of putting a hovering safety agent over it, but I don't know why. Rifles. Okay, another thing that I worry about is terrorism. People getting guns and shooting them in places like this where you should never be shooting a gun in the first place. Those rifles have sights. Computer vision works well enough today that we could put a camera looking in the sight. It wouldn't be hard. And if that sight is fixated on a person, the gun could simply refuse to shoot. This is totally doable. If in the sight it's clear that we're in an indoor building, the gun could refuse to shoot. If the GPS sensor in that rifle said that we're in a stadium, the gun could refuse to shoot. It's simply a matter of getting out of the mindset that we can't go back to old things and put in new safety systems. People can still have their guns and be fine. It's just that instead of having a mechanical safety, that's what guns have today, a little lever that you flip when you want to shoot it that prevents you from accidentally shooting it. That's what we have today for the technology, for safety for guns. You could put AI systems on top of that, use today existing technology for perception, add safety to an existing system. Point 3 is one that other people have made better than I have, I think, or better than I have time to already, which is that, in fact, AI systems also pose safety issues. They're not just, we can't think of them solely in terms of how we would use them to make other systems safer. And many of the reasons, and these have been discussed, I think, well today, are familiar issues about software, complex software. It makes it hard to design them error-free and so forth. There is a novel issue with AI, which has to do with learning, as Richard talked about. And there are also some sort of self-imposed, human-generated opportunities to use AI to cause disruption. AI viruses is actually one of the if I try to worry about the future, then AI viruses is one of the things that I find that I can successfully worry about. Because the AI virus in here that was smart enough could intercept the calls that are coming into me, could impersonate my voice, can do that easily already, but if it was really smart, it would know what to say to convince my bank that I really did want to transfer my funds to Switzerland and to this other account and so forth. So I think purposeful uses of AI for dangerous things is another kind of angle for us to think about in terms of safety. Okay, I promised 2 recommendations. These are pretty easy to guess from what I've already said. One is, I think we should, safety is a very important issue, but I would suggest that we think about framing the question this way. How can we make complex systems safe in the face of diverse sources of failure? Human caused, machine caused, accidentally caused, purposely caused. And I think if we frame the problem that way, we have a better chance of doing research that will give us truly safe systems of the type we like. Because it won't be that AI is the only cause of safety problems. So that's recommendation 1. Recommendation 2 is, if you think about I think one of the tensions that we have in this meeting, in this discussion, and thinking about how to deal with safety in AI systems and other systems is it feels like many of the techniques are down in the details, as Eric said. They depend so much on the specific application. How do you make a car safe? That sounds so different from how do you make a nuclear power plant safe. And I think at some level, they really are very different problems. But if we want to develop some general technologies, then I think this is one area where we might try. So let's think about what it would mean to design a safety assistant, AI safety assistant, that can be added onto, hover over a nuclear power plant, or a car, or the airline security system, or the financial system. And the sensors may be different in those 4 different applications. The effectors may be different. But in all of those, we're going to want a system that can be told initially conditions to monitor for and how to respond to those, and can also subsequently learn over time how to anticipate those triggering conditions before they actually occur. In the same way that disk drive manufacturers 10 years ago started building disk drives that would anticipate that they were going to fail before they did, so that you could replace them before you lost your data. So there are some kind of generic techniques, AI planning techniques being compiled into rapid response reaction techniques through reinforcement learning and so forth. So there are some techniques that can be studied at this level of detail. And I think it remains honestly an open question of how much of the final solution is for building these kind of systems would be in terms of generic AI techniques versus how much of that final solution would inevitably have to be idiosyncratic to the application. Okay, so that's what I have to say. Thank you.